Lead code problem, find peak element. So for this problem, you'll be provided with an input array, and we need to return the peak element or the index of the peak element inside of that array. So the peak element is not like the maximum value inside of the array. Instead, what it says is that the array will be in a sorted order until a point, and then the values will start reducing. So we need to return the point at which it goes to its peak and then starts reducing. So as an example, they have given this input array 1, 2, 3, 1. So it is in a sorted order for the first three numbers, and then it reduces to 1. So here the peak element will be 3. And it's possible that inside of the input array there'll be multiple peaks. So here it goes up to 1, 2, and then reduces back to 1. And then it starts increasing in 1, 3, 5, 6, and then goes back to 4. So either of the two indexes, you can say either, the index of 2 or the index of 6, they're the peak elements. And also another thing they've given to help us is that nums I will never be equal to I plus 1. So when you're doing a comparison between two neighbors, they will either be in increasing or decreasing order. So usually when candidates are given this problem, they try to solve it using a linear search. So they traverse down the input array and they compare each value with its neighbor, and they find the point at which it's no longer sorted. So that works, but the solution will be of O of n time. Whenever something is sorted, I think it's a tip for candidates is that there's always a solution using binary search. So we can take advantage of binary search to find the element where it reaches its peak. So yeah, let's try solving it. So like regular binary search, we'll create two pointers, and we'll use it to find the midpoint, and then we'll use that to reduce the size of the elements in the array. So int left equal to 0. So yeah, we have two pointers, left and right. So while left is less than right, we'll do the processing. If both the values are the same, we just return left. So this is a case where they pass an input array of size 1. We'll just return the element inside the array because that's the peak element. Now we'll try finding the midpoint. So int. So now after finding a mid, we need to compare it with its neighbor. So if the value is less than its neighbor, so we know that it's now in an increasing fashion. That is, the array has the values keep increasing on the right. So the peak element will be somewhere to the right of the midpoint. So we say left is equal to mid plus 1. Else, the value is in the decreasing order. So since it's decreasing, it could be the mid is the largest element, or it could be like somewhere on the left side of mid. So we say right is equal to mid. So we've already determined that nums of I will never be equal to I plus 1, so we don't need to check equality condition here. So yeah, there's an example. Let's try running it. Oh, I can see a spelling. Min, okay, spelling. Try it again. All right, the 3 use cases have passed. Let's try submitting it. So yeah, the time complexity will be O of log n because we're always using the midpoint. And based on what we are we are able to cancel 1/2 of the array. So in that we keep reducing the size of the array which we are processing. And the memory complexity, so the entire thing is being done in place. So it's O of 1 space complexity.